All right, well, here's a few news items. I just saw this one, which is pretty interesting. The ISIS had propaganda, and the Democratic group is trying to counter Trump's activities. So they are taking a former general, Stanley McChrystal, is going to take technology to try to combat Trump's statements with a group called Defeat Disinfo. And this does appear to bring up some ethical concerns because they're going to use artificial intelligence and network analysis to try to post content to oppose Trump's content. And they're going to be boosting it through 3.4 million influencers, including paying people to take position. And Bloomberg did this too. Almost all of Bloomberg's online support was he paid people to post pro-Bloomberg memes or something. And so they're doing this too. This is the troubling thing about free speech. If you have free speech, then you get paid free speech. And it is hard to decide. And this is the kind of situation where the Supreme Court, in their controversial Citizens United ruling, ruled that in America, money is equal to speech. And you cannot limit the amount of money people spend to promote political ideas because that amounts to limiting their votes. It's an interesting issue. As this is one of Bernie's big campaign issues, is we got to do something about the huge amount of money that influences politics in America. But it's right now, it continues to be a really big factor. I was very amazed by this video, although I'd like to get rid of the sound. There. So in Japan, their robots are amazing. And so they have made robots that throw bottles onto these tables, and they even bounce them off trampolines and throw them onto that table. So they're very impressive. We saw the on-campus robot competition last semester, and the instructor in engineering that was doing it said Americans had pretty much lost interest in robots, so the Japanese are still charging ahead. But they really have some impressive robots. They also make robotic humanoid companions. They've got some robot girlfriends you can get and such. So, I mean, robots are still very popular in Japan, and making them is very popular in Japan. They've fallen out of favor in America. But anyway, they are very impressive. So now this is pretty amazing. These guys made a pandemic drone, and the goal of this thing was to fly around and find people who are infected. So they made a version that will tell you if people are not social distancing. And I thought I saw a video of that earlier, but I may not be here now for some reason. But anyway, one of them will just go around and identify people who are standing too close to other people. And then, yeah, this is the one. This is the social distancing demo. So it flies around with a camera, and it turns the background red when it detects that people are closer than they should be to each other. Although I think at this point it doesn't do anything about it. But that was their original demo, and a lot of people were interested in buying that. But then they went ahead to one that will do fever detection. It will take your temperature with something like an infrared camera or something. So it'll detect, that's the first thing. So then it could, I guess, be sent to something that would send a message to your phone or send a cop to arrest you or something. And now they have something that can detect coughing by reading your motion. So I guess I don't see how it's obvious here that it's detecting it. But anyway, at this point, people got worried about privacy concerns and such. And anyway, but they're trying to make these drones, and they'd like to sell them to governments and agencies to fly around, perhaps private companies. We'll see what comes of all that. In India, they are making everybody, even if they work for a private employer, download this app and put it on their phone. This is another app that does coronavirus tracking. These things are big all over the world, many of these coronavirus tracking apps. And so there will be punishment if you don't use this app. The current apps are prototypes and don't seem to work very well. And there's a huge privacy concern and civil rights concern about making people use them. in America. In other countries, they don't seem to have that much worry about that. And so here's another one. Now, if you work at home, managers are getting apps and turning on webcams to force you to prove that you're really working if you're at home by broadcasting a constant video. There is software from San Francisco that will do this, Pragly. So I know they had one like this a few years ago that would run at work. It would have a camera under your desk to take a picture of your legs to see if you were really at your station or if you'd wandered off. And again, people got quite worried about it. Now, that's probably not illegal in America because you could just quit your job, but it certainly is something that people might not like, and then they might not want to work for an employer that requires a thing like that. In a similar spirit, here's ankle bracelets. You wear these ankle bracelets, which turn out to make a lot of trouble. It's supposed to tell people if you're home like you're supposed to be, or if you've wandered away. So now they're putting on smartphone apps, and the smartphone app makes it possible for them to test many times a day to see if you're really there. So every time it makes a noise, you have to pull out your phone and answer. And apparently it's defective, so it will bug you so you can't get any sleep. It'll interrupt you when you're at work and get you fired and so on. And here's the app. So the app is publicly available. I would sort of like to download this app and try it out and see how it works. You can get Tellmate Guardian. I may download this and see if it's fun to play with and talk about it in the mobile device hacking class. Anyway, so Bezos is being called in to testify because Amazon has been accused of doing the same thing Apple has been doing for years. They let third-party sellers into their store selling something, and if they sell something and it's a success, they will then make a copy of it, kick them out, and sell their clone product. Apple does this to apps. They've done it for years in the App Store, and it's some form of crime. I'm sure it's something along the lines of abuse of monopoly power or something. And Amazon has already officially denied doing this, and now apparently having to admit that they really do it. So there may be some form of punishment, but so far as I can tell, a lot of civil libertarians have been calling for years for breaking up the major tech monopolies like Amazon and Facebook and Google, but it is likely that the pandemic response has totally overshadowed that, and none of it's going to happen. The only thing I think that could possibly endanger the techs would be a Democratic victory, and really in that case only if Elizabeth Warren was the vice president. Probably not even then. I really think neither of the candidates are likely to do anything about it. I think tech is probably going to skate for at least 4 more years. So Musk runs Tesla, which is fantastically successful, but he does a lot of crazy things. And he seems to spend a lot of his time at home having fights with the girlfriend, getting high and tweeting stupid things. So he tweeted the stock price was too high, so the stock fell. Then he tweeted he's going to give away all his possessions and sell his house and have no house and all sorts of things. He seems to be sort of cracking up and melting down again, which he tends to do. Anyway, so this is the last or next to last class in this class. I'm at 2 o'clock in an hour. I'm going to do this COBOL CTF for Pacific hackers, and you folks can do that if you like for extra credit. Although COBOL is sort of a crazy thing to learn. It's almost a dead language, but it's gotten a lot of news lately. It caught my attention, and I decided to learn some COBOL and write a CTF in it. So it's fun for some people, and mainframes are interesting to learn about, but they're not in all a high priority item for people to learn to get jobs these days. Anyway, we're going to do chapter 16 and 17 today, which there isn't any hands-on anymore in this class. I'll explain. I used to have it, but I took it out. And on the last class, I'll probably demonstrate a few ARM attacks. I don't think I'll bother with .NET, but you'll find out next week if you tune into that. And that's the end of this class, except for the final exam. All your scores are in Canvas, and the rubric to determine your grade is there, so you should be able to predict your grade. And if you need more extra credit, there's tons of extra projects to do, including the COBOL project. But like I say, I would do the normal projects first if you are on a practical path to get employable job skills. Anyway, so we'll talk about fault injection. Fault injection is an old trick. I've heard it started from people using a dial-up modem during a thunderstorm, so random signals would come down the wire and then they observed things crashing. So it's always been a case that if you're taking data from any wire, or even electricity from any wire, you should consider what would happen if there were defects in the signal coming in. So quality assurance teams are the people that do this. They test your devices to see how they handle these faults. And so here's the basic idea. The design of the system is you'll have client software running, and you have server communications. And so now you inject faults into those communications where you feed in something broken or defective, and then you use some kind of sniffer to capture the traffic and see if you find defects in the results. So the only trick is how to determine the input. So here, and it turns out, of course, that the primary functionality of an app tends to be tested. The developer and the normal quality control teams will quickly catch it if it doesn't do its primary function, with a few exceptions like that that app I mentioned. I don't know if I went in the news today, there was an app that was supposed to detect if you were close to someone and possibly going to infect them with coronavirus, and it just doesn't work at all. But that's rare. If an app doesn't do its primary purpose under normal conditions, it usually never gets published. What's far more common, though, is you'll have some small edge case of functionality that isn't tested very well. And here there's a type of file called an IDA file, whatever that is, that's almost never used. And so they're going to try sending requests using that kind of file, and you're more likely to find defects in that kind of rarely used functionality. So if you want to generate input, you could just understand the protocol and then deliberately figure out and type input into a text editor that has defects in interesting ways. If you know what you're doing, of course, you can apply intelligence and make a high quality test case that's more likely to find faults. But the automated generation is, of course, easier and faster. It's less accurate, though. It's just going to put in some kind of generic kind of fake input, like make all the inputs really long, make all the numbers really big and small, and that sort of thing. So if you can do live capture, this is a simple way to do it. You can capture real traffic of the app under normal circumstances and then just modify it, flip fields and so on. All right. So open source apps, you have the code, so you could recompile the code with special added code to improve fuzzing. And that's what American Fuzzy Lop does. It does, you recompile code with special flags, and then you use that to more efficiently exercise the entire code. That's a pretty complicated process, and I decided not to try to include it in the projects. Then you can have engines that modify the data. So it takes all the elements and injects variable size data, non-alphanumeric characters, and so on, injects into elements. So if you have a basic request like this, like an HTTP server, and you send a normal request to just see the web page here, you might wonder how you would fuzz this to find defects on the server. And you'd fuzz it by, you can just take a fault, like EI 2003, and you just inject that fault in the first verb, in the beginning of the first verb, in the middle of the first verb, at the end of it. Here you just put it in first character, second character, third character. You just inject that into right on top of the existing stuff, just substituting some of the characters with that fault. That's one way to do it. Another way to do it would be to just put it at the beginning and end of each firm. Here you put it after the get, here you put it before this part. Here you put it after the slash, but before the index. Here you put it after the index. You try to put it in sort of intelligent places where it might make a difference. Then other thing you could do is, if you don't want to inject random characters because they'll be filtered out, you could just repeat the existing characters. So put in more T's, put in more slashes, put in more X's to see what will happen there. And this way you have a higher chance that the injected data will be processed deeper in the system. There's a concept called code coverage, which is how much of the code did you actually exercise. Most apps have a whole bunch of error handling code that's almost never used. And under normal conditions, you only use maybe 10 or 20% of the code. And so that's what you need. Things like modifying code, using things like the American Fuzzy Lop is a fuzzer that will really try to reach all the code. If you just try to reach all the code with this kind of modification, you usually fail. And there's a bunch of code that is never actually reached. So now you deliver the code. Now, it's pretty sloppy to just send a lot of network packets and wait for it to crash. One of the many things wrong with that is the Nagel algorithm. Modern network drivers stacks do not actually send every packet one by one. If they have a bunch of small packets, they will group them together and send them all at once. So if you're sending a bunch of attack trackers and attack number 50 causes it to crash, it might not respond at all until attack number 60 or 70. So your association of the crash with what you sent might be wrong. So it would be nice to disable the Nagel algorithm while you're fuzzing. And you can do fault monitoring with the debugger. This is the most accurate, the way we've done it here, where you're actually running the app within a debugger, and when it crashes, the debugger will show you exactly what line of code crashed and why it crashed. That's nice, but of course, that's pretty much a manual process. All right, and then there's more about fuzzing here in the next chapter. So you can do static analysis. You can just look through the code for dangerous patterns, like when a string is copied into a string variable and there's not a command right before it to check how long it is, when there's a print statement without a format statement in it. So you could find things like that. But in fact, most of the ones you find are not exploitable, because even though it does handle something in a potentially unsafe way, it turns out that the data it's handling was just created by the program and not by the user. So that data never happens to have the dangerous value. That's why fuzzing is more effective in the sense fuzzing doesn't find all the bugs, but the bugs it finds are almost always likely to be exploitable, because they're bugs, well, a lot of them still are not exploitable in the sense that you can't turn them into rote code execution, but they are certainly bugs that are triggered by user input, because you're using user input, and that it passes that test. We did run Fuzzer for one of my students a few years ago in this class, ran for months, ran Fuzzer against some things, just didn't find anything very good. It's harder to find bugs that are really exploitable with fuzzing than you might think. All right, if you were write a generic fuzzing engine against a common protocol like SMTP, then you could use it against any SMTP server, right? Because they're all supposed to be doing the same thing. So the same set of test cases would seem reasonable. So you can try putting in simple strings that apply to everything, like attempt to do a directory traversal with .. or just long series of A's like we've been using and such. Like I say, the problem is the fuzzer won't hit all the code, because there might be some requirements for the code, the input to have a certain parameter, or have certain code, have certain traffic before it to get to that part of the app. And just like a vulnerability scanner, your fuzzer is probably not smart enough to really go in there. All right, so you have to use static analysis and runtime intelligent binary analysis. The same thing's true of vulnerability scanners. You run a vuln scanner, it gives you a report, then you have to go back manually and verify the reports from the vuln scanner, and you have to go manually and look for the things the vulnerability scanner will miss, or you aren't going to do a very good job of finding the vulnerabilities. Spike is a generic fuzzer, and I used to have hands-on projects with Spike, but I took them out because I thought it wasn't very effective. But Spike has the ability to just sort of generically describe attacks, which it will then send. So this was the command that will send the string hello world. This will append variable strings. This will send a variable string starting with message and then drawing from a list of standard strings it tries. You can read a line from the server. So here's something this is the one that will fuzz the vulnerable Windows application we've been using, where you had trun and then it sends things. You send trun space and then a variable command, and it will send all sorts of things. And as you remember, this one had a simple buffer overflow where all you had to send was trun space, a period, and then 2,000 or 3,000 characters, and it would crash. And this will find that right away. So it will send things through, and the server will crash quickly. But that's what it does. Here's a vulnerable server, and it doesn't even respond by the second one because it's already crashed, because the second fuzz sent 5,004 characters, and that's enough to make it crash. So it will work against very simple cases like Bowne server, but it didn't seem to work against much we tried it against in practice. And I decided there's not much point practicing with this simple Spike tool. We really need a stronger tool, but the other stronger tools are very complicated to set up. And I don't currently have any hands-on fuzzing projects in this class for that reason. I haven't found a good one that isn't too difficult to set up. Anyway, here's another one that came out recently, is Cluster Fuzz. This is a Google product, and there's now cloud fuzzing resources and such. This might be the one, there's a Google project that we're going to constantly online scan code bases, connect to GitHub code bases and look for errors in them. There's a huge lot of interest in vulnerability scanning and code scanning, especially for open source projects, but none of it has gotten very easy to do at the level of the projects here. All right, and I don't think I'm going to do the Kahoots with only 3 students. Does anybody have any questions? Well, I'm going to stop the recording.